Hello. In this lesson, we are going to review operations with radical expression. First thing you remember is the concept of like radicals and unlike radicals. For like radicals, we would have something like square root of 3, 4 square root of 3, negative 2 square root of 3. So we have the radical square root of 3 are the same. Unlike radical would be something like 2 square root of 4, 2 square root of 5, 3 square root of 6, negative square root of 3, right? So you can use the distributive property to simplify sums or differences of radical expressions by combining like radicals. So let's do some example. I have 6 times square root of 11 plus 9 times square root of 11. So again, these two numbers are like radicals because they have the same radicals as 11, square root of 11, and thus you can actually put the square root of 11 out, and inside you have 6 plus 9, or 6 plus 9 is 15 times, this is multiply, right? Multiplied by square root of 11. Another example would be 3 square root of 3 minus 5 square root of 3. Again, these are like radicals, so you can use distributive properties, right? Square root 3 out, and inside you would have 3 minus 5, and 3 minus 5 is negative 2, so remember to write the negative outside and 3. Another example, we will have square root 3 minus 5 square root 3. Okay, in this case we will assume, okay, so we don't have any number out in front of the square root of 3, but actually this is 1 times square root of 3. So you would write down as square root 3 out, and then because this is a number 1, minus 5. So we would have 1 minus 5 is negative 4, and times square root of 3. Another type of example you would see in the test would be 5. You have to do a little bit of extra work. For example, in this case, 5 times square root of 3 minus square root of 12. So square root of 3 is the most simplified form, right? You cannot simplify any further. But square root of 12. Now remember that 12 equal to 1 times 12 equal to 2 times 6 and 3 times 4. Again, among these 3 factors, you can see that 4 is actually the perfect square. Okay, so 4 is a perfect square factor of 12. 4 is a perfect square factor of 12. What does it mean? It means that square root of 4 is 2. Okay, so in this case you would rewrite square root of 12 as a square of 3 times 4. Also remember that when you have square root of a times square root of b from previous lesson, this would equal to square root of a times b with the product a and b under the square root, provided that a has to be greater or equal to 0 and b have to be greater or equal to 0. So again, 5 times square root of 3, you rewrite that, but then square root of 12 you would rewrite it as a product of 3 and 4, and apply this property. You would have 5 times square root of 3 minus square root of 3 times square root of 4, and you have 5 times square root of 3 minus square root of 4 is 2 multiplied by square root of 3. And again, in this case, you would use distributive properties to solve this, to simplify this, which is equal to 3 times square root of 3. Now, if you already familiar with this, calculating the sums or differences of the like radicals, you can actually go from this to this, okay, and you can skip this immediate step, okay. Another type of question that you may see in the test is multiplying radical expression. Okay, so for example, what is a simplified form of this expression? Square root of 10 times square root of 6 plus 3. In this case, you would use distribution property again. Distributive property, you would multiply square root of 10 with square root of 6, and then later on add it with the square root of 10 times 3. So in this case, I would have square root of 10 times square root of 6 plus square root of 10 times 3, and then I have square root of 10 times square root of 6, which is equal to square root of 10 times 6 plus 3 square root of 10. Okay, and again, square root of 10 times 6, which is square root of 60 plus 3 times square root of 10. Now, again, in this case, like square root of 12, you need to find a perfect square factor of 60. Okay, so 60 we would have 1 times 60, 2 times 30, 3 times 20, and 4 times 15. Okay, again we have 4 is a perfect square factor of 60. So in this case, we would rewrite square 60 as square root of 4 times 15 plus 3 times square root of 10, and you would have again square root of 4 times square root of 15, okay, plus 3 times square root of 10, and square root of 4 is 2, square root of 15 plus 3 times square root of 10, and in this case it's more simplified, so you cannot simplify any further. Okay, another example would be rationalizing a denominator using conjugates. And remember that a conjugate or conjugates, okay, are the sum and difference of the same two terms. Okay, so it's sum and difference. Okay, sum and difference of the same two terms. So for example, I would have square root of 7 minus square root of 3 and square root of 7 plus square root 3 are the two conjugates, okay? Because this is a sum of square root 7 and square root 3, and this is a difference of the same two terms, alright? So these are conjugates. Now, remember that there's also a perfect square trinomial, a special case. So when you have a minus b times a plus b, you would have this would equal to a squared minus b squared. And if you observe that if this is a and this is b, and you have a square root of something. So for example, if you have square root of a and you square it, the square root will be eliminated and the result would be a. Okay, so for example, if I have square root of 7 minus square root of 3, and if I multiply this with its conjugate, which is square root of 7 plus square root of 3, I would have equal to square root of 7 square minus the square root of 3 square, and I would have 7 minus 3, which is equal to 4. Okay, so we will use this observation to eliminate the denominator. Okay, so in this technique we call rationalizing, okay, a denominator using conjugates. So for example, I have 10 divided by square root of 7 minus square root of 2. Okay, and I want to simplify this. Simplifying this expression means that you want to eliminate the radicals under the denominator. Okay, so we know that square root of 7 minus square root of 2 and square root of 7 plus square root of 2 are conjugates. Okay, and we also know that if you multiply these two conjugates together, you would eliminate the square. So for example, if I multiply the denominator with square root of 7 plus square root of 2, so to honor the balance here, you have to multiply the numerator with the square root of 7 plus square root of 2 also, okay, because these two will cancel out, okay, equal to 1, and then this will give it back as the original expression. So let's look at the denominator first. In this case, it's exactly the same as an example of both. So you would have square root of 7 square minus square root of 2 square, right? And in this case, you would have you will have 10 times square root of 7 plus square root of 2. Just keep it, and it is right for now. So square root 7 square would be 7. Square root 2 square would be equal to 2. Okay, and here on the top, just write it. Just keep it like this. And then you would have the denominator here is 5, and then you would have 10 times square root of 7 plus square root of 2. Okay, now 10 divided by 5, which is equal to 2, times square root of 7 plus square root of 2, and then you multiply it together out, you will see 2 times square root of 7 plus 2 square root of 2. Okay, so this is simplified.